Hello everyone, this is How I Love Geometry. I'm Mr. Chao. Today's problem is about the sum of an infinite sequence. We know triangle ABC is a right triangle. It has a right angle at C, and AB is 4, BC is 3. Of course, AB is 5. CC1 is the altitude of the hypotenuse AB. Then we do the perpendicular or from C1 to C2, assume. Then we can go on C2 to C3, and here also the right triangle, and C3, C4, and so on. C4, C5, C5, C6, right? And the problem let us to calculate the sum C1, C1, C2, C2, C3, C3, C4, and this is an infinite sequence. So for this type of problem, what's the most important? Yes, of course, we should find the pattern to represent each term. Regularly, this should be a geometric sequence and the common ratio less than 1. Otherwise, the sum of this infinite sequence will not converge. It will go to the positive infinite. So the most important thing now is to find the pattern of find the general term formula, right? We can find the recursive formula. So for this probably is in a right triangle, so we can use the help of this angle. See, if I say this is alpha, of course we know is a similar. All of them are similar triangles. This one, triangle BCC1, right? BCC1 is similar to BAC, and this one, triangle CC1C2, is also similar to this small right triangle, also similar to the large right triangle. So if we suppose this angle is alpha, so this angle is complementary to the alpha, and this angle also complementary to the alpha, so this angle will alpha. And this is perpendicular, and the perpendicular we know they are parallel, right? Yes, parallel, 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 parallel. And the same thing for this parallel, 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 right? And this is alpha, this is alpha, and alpha, and alpha. This is alpha, this also alpha, alpha, and this is alpha. Now, we can easily to find CC1, right? CC1, we can easily use the same triangle. We will got the same area. So we can use 1/2 of BC times AC. That's the area of this triangle. Also, we can use AB times CC1 times 1/2 of this right triangle. So we will got CC1 equals 3 times 4/5. So we got 12/5. Yeah, CC1 we can easily get. And also CC1 can use this way to represent. I mean, we can use BC, right? we can use CC1. Also, we can use BC times sine alpha. You see, sine alpha, the opposite side over hypotenuse. So CC1 also can represent use BC times sine alpha. Yeah. And how to use CC1 to represent C1, C2? Yes, it's easy, right? Because in the triangle C1, C2 is the same thing. C1, C2, this leg, or we can say this side, CC1 equals CC1. Here is C1, C2, C1 times sine alpha. And we know, now we can use this CC1 to plug in here, right? CC1 is B equals, CC1 equals BC times sine alpha. And here, another sine alpha. So, equals BC times sine squared alpha. Then we can go on for C2, C3 to find the pattern. Now, the pattern is almost appear, because you see here is BC times sine alpha to the first power, right? And here is BC times sine to the second power. Then we just want to make sure if we can represent C3, C2, C3, here is 1, here is 2, C3, to be the BC times sine cubic alpha, right? If it's so, then we find the pattern. Of course, you see, C2, C3 is this segment equals C1, C2 times sine alpha. C1, C2 we can use this to plug in, substitute, or see, BC times sine to the second power sine alpha, right? Then times sine alpha. So it's equals BC times sine cubic alpha. Yes, we find the pattern. The pattern is the next term equals the term just the previous of this term times sine alpha. So we will easily to think about Cm minus 1. Cm will be BC times sine to the nth alpha, to the sinus alpha. So we will just find BC. Yeah, we know BC is, BC is 3, we don't need to find. And the sine alpha from the view of the largest right triangle ABC, sine alpha is AC over AB equals 4 over 5. Now we can calculate the sum of them if I use S to represent the sum we wanted to find. So S equals C1 plus C1, C2 plus C2, C3 plus C3, C4. And so then, because we know the common ratio is sine alpha, right? The common ratio is sine alpha. So we can times sine alpha left hand side and right hand side at the same time. Sine alpha times S equals the first term C1 times sine alpha. C1 times sine alpha, CC1 times sine alpha, CC1 times sine alpha equals C1 C2, right? C1 times sine alpha, C1 C2 times sine alpha, this one, and C1 C2 times sine alpha is C2 C3. We know this is, this here, yeah, times sine alpha, C3 C4 is the same thing for all of them. Now, this, if I say this is equation 1, this is equation 2, then we wanted to find the S, we can use equation 1 minus equation 2, right? We will get S times 1 minus sine alpha equals, so all of them cancelled, right? Yeah, whatever. And here only C1 was left. Then we will find S equals C1 over 1 minus sine alpha. CC1 is 12 over 5, and here 1 minus sine alpha is 4/5, so it's 1/5 was left. So the final answer is 12, right? No problem, yeah, it's 12. And here to find, when we wanted to find the S, we can also use the formula. Is A1 over 1 minus common ratio R. A1 is the first term of this geometric sequence. Here, A1 is CC1. CC1 is 12 over 5. Common ratio we know is sine alpha. Sine alpha is 4/5. 1 minus 4/5 is the same thing. 12, right? Yes. We can use, if we are familiar with this formula, we don't need to get this process, just directly to use the formula to get the final result. And I just want to say Aime12 problems of 2016 is almost the same as this one. So we can use the same idea to solve this Aime problem. And the most important, I just want to make a summary. Yeah, most important idea about this infinite sequence, the sum of this infinite, almost this type of problem, I just want to say. So regularly it will be a geometric sequence, and the common ratio normally will less than 1. The most important is to find the pattern. Yes, just like this way. Sometimes it's for the sum of the segments, sometimes of the infinite sequence of the area, maybe sometimes is about the infinite sequence of the sum of the angles. All of these problems almost the same idea, right? Yes, here is the best point to stop. I hope you can enjoy this one. Yeah, have a nice day.